All right, so today what we're going to do is we're going to be kicking off again with Chapter 9. This is organizing files. This is a direct follow-up to our last chapter, which was reading and writing files. In the last chapter, some of the things we did is we learned how to open files, we learned how to read from them, we learned how to write to them, and today we're going to be playing around with moving files, deleting files, all of that kind of stuff by extension. Now, I would say that the tasks are pretty similar, and you're going to find everything you want to do from last class onward is pretty similar. I kind of view it like this. Let me show you how I think that we've hit a benchmark and we should be celebrating that. Chapter 7 is pattern matching with regular expressions, right? That was, anyway, this isn't last class. This was actually the class before that. That was the last chapter where we covered functionality that was specific to Python. Every other chapter we're covering is things that are actually practical, that are task-oriented, right? So when we're doing pattern matching with regular expressions, we're learning a computer concept. We're learning a sublanguage that teaches us how to modify text, right? When we do Chapter 8, we're reading and writing files. We're learning how to actually manipulate stuff on our disk on the operating system. Chapter 9 is organizing files. It's moving them and deleting them. Chapter 10, we return back to programming. And then Chapter 11, we're back to doing what is more administration. It's more practical stuff, right? So debugging, computer programming, administration, all this stuff here that says working with, that we're actually going to be doing like exercise-based stuff, right? You're not going to come out being a better programmer, but you're going to come out knowing how to do more things with the programming skills we've built. We're going to be showing you more things to do with that. So you're going to see that these chapters feel different too, right? And they're going to feel different because you're not going to have to twist your brain to learn a whole new language to do regexes. That stuff is really cool, but what we're going to be doing is simply applying what we've learned. All right. So let's go ahead and review a little bit on the last chapter, which was reading and writing files, right? All right, we got this guy right here. We call this a directory. We see here this user bin spam that we're creating with the user bin and spam, which are part of those. Actually, they're not part of the one above, but they're part of a hierarchy. We have this getCwd. Who remembers what that stands for? Current working directory, right? And that is what? Anyone remember what that represents or what that is about?
Where the program's executed.
That's exactly right. Where the program's executed, the environment the program starts up in. And why is that important when we're talking about files? Why does it matter where we start up our program in? That's exactly right there. It's because of relative path names, right? So if we want to find a file inside of the directory, it depends. Wherever we start up in, we're going to find different files. So when we do relative addressing, where we start up in is very important. If we do absolute addressing, is it important? Does it matter at all? What do we say? Not at all, right? If we do absolute addressing, it doesn't matter where we start up that stuff. Okay, so we have this concept of chdir, right? And that's simply going to move you to a different relative address or absolute address. It doesn't matter, but it's going to give you a different ability to do relative addressing. If we're in the C drive and we say we want to go into, let's say, the folder foo and find the file bar, it's going to make total difference whether or not we're in root C or we're somewhere else entirely. And we can use chdir to change those relative addressing, the relative addressing. We talked about this before. We use this as an example. We said if we're in fizz, right, we're going to find a different spam.txt than if we're in bacon. That's what we're talking about when we say relative addressing. It matters where you're at. Okay, os.makeDirs. This is just one easy way here of creating directories. And you can see here that when you create those directories, it doesn't just create delicious, it creates delicious and waffles for you. So it creates all of the directories that you need. Right, os.makeDirs. We're going to see some things in this lecture we're going to do today that are oftentimes similar. And what I mean by that is you will find things that exist in OS that are the same that we're going to cover today. We're going to cover more of that. But notice in this chapter, we really focused a lot on OS and os.path. That was the majority of it. How do we work with paths and how do we work with the actual files, reading them? All right, let's go through and pick out some other stuff we can ask questions on. os.path.getSize, that was real simple, right? We returned a simple size of that file in bytes. And then what we can do there is we can take os.lister and it shows us all of the different file names. And then we did an example in the class where we iterated through that list, and we said for each different file, calculate us the size using this os.path.getSize, add them up and give us the sum. We did this here. We said hello file.read, right? So what we do is we open up a file with this open command. We went through this. You can open a file right here with whatever path you want to give it, and you give it a mode, right? We have R as the mode here. What is the other mode that we looked at? W, right? So R is the mode to read a file, but we also looked at how to write a file. So you can open up a file two different ways, right? So we can read the file, we can write the file. There was one more, I think we covered append too, which actually, there we go, with the append mode. Yep. Pass A to it, and then when we write to the file, we don't clobber it. We don't destroy the old one, right? So we went through that too, covered it. And then we covered this thing here, shelves, right? So we're going to go through that here too. This is the shelf module. And we said what that does is it gives us the ability to take these Python objects that we have, right? We can take them and make them into essentially strings. Take a complex Python object like a dictionary. Let me show you some of this stuff here. There we go. So we can take a we can say something like let A equals foo bar. Oh, nope, I'm not even thinking here. I have been working way too long today. A equals there, foo bar. And now we have an actual Python object. This here is a dictionary, right? So we have a key foo and we have a value bar. And what shelving is going to do is it's going to take this object and it's going to create a file that stores that object, and we can read it back later. So when we went through that, let's see if this works. Boom. We went through that. We take it here. We create a shelf. We open up a file called myData. We create this Python object here. This is just their example. It's an array with 3 things in it. And then we add it to the shelf. We shelve it, right? And then we close the shelf, and it's done. And we can do whatever we want with that. Here we're opening a file, right? So we open the file myData. And what you'll see here is when we call shelf open, then the shelf file actually has in it cats. Just pulls that object right back out. So the purpose of this, just to recap on it, the purpose is we can create these objects in Python, but if we ever want to save them for later, we didn't have a method of doing that before this class, right? So we showed off shelve as saying this is a method where you can create a program and save it and then resume it later. All right, and then we went into some of the examples, right? And in that example, I think one of those examples we created the city capital thing, and in the other one we did the password manager, right? Random quiz generator and password manager. And I'm not going to go back through them. All right. So there's our 10-minute recap on 3 hours of Python in the last class. Now let's go ahead and kick off with organizing files. So when it comes to organizing files, you can see here some of the tasks that we have when we're organizing files. These are the examples that they give us. But likely you'll be coming up with your own. They'll be totally different. But making copies of all PDF files and only the PDF files in every subfolder of a folder, right? So what does that mean? Does anyone have an idea what that kind of task entails? Anyone with any programming experience before? Recursion, that's right. So what we're going to do with that is we start off in a directory, wherever you want to start, and you go through and you start to look at the things in the directory, right? And you say, is this a directory or is this a file? And if it is a directory, you have to recurse into it. Then if you're only going to copy the PDF files, you have to say, is this file that I find a PDF? And if it is, I need to copy it. And where am I going to copy it to, right? So there's an example of something where we're filling in with this lesson here. Removing all of the leading zeros in the file name for every file in a folder of hundreds of files named spam 001, 002, 003, and so on. Right? So for this, you go through a directory, you find a bunch of files. You have to know how to parse the text of that file name. So you get the file name from that os.listers. We saw that in the last class, right? We saw how to do that. So now you have a bunch of file names. You store the old one. You look at the new one. And you say, how am I going to manipulate it? Right? Now, a file name is a string. So we talked about some of those things we can do, right? You can concatenate strings. You can put regexes into strings. You can do all that kind of stuff. So you parse the string, and then you simply rename the file, or you move the file. Compressing the contents of several folders into one zip file. Okay, that's a little bit more complex, and that requires a library. So let's go ahead and start off here. This is SHUtil, or shell utilities, right? When you work on a shell, first thing, does anyone here, if you don't have any experience with programming, you probably don't know what a shell is. A shell is this thing. When I hold that and I hit enter, I've just popped up 2 shells. This is very useful for programming, right? It gives you the ability to do specific things, right? Like I can take it and I can say something like mkdir, and then I can say test. Of course, that's got to happen when you're doing it. Is. Okay, let's jump into it and see what I created last time. There we go. So I have this directory called test, and inside of it I have 2 files, foo and foobar, right? I can delete those files by saying rm foo. Of course. This is a Mac issue, by the way. I would expect that to be a different color. I don't even know how to make ls colored in a Mac. G. There we go. That's what I'm used to. Alias L equals LSG. Let's not do that again. Okay. So you can see here that I have a directory foo and a file foobar. I can do different things with it. I can create a new directory if I want. This is all doing it in what we call the shell. I can see again what I have. I can delete the file I just created. We can go into different directories. You can see all these commands I'm using. ls, or in this case L, because I didn't want to do the whole G thing with the colors. That's a Macism. But I have rm and cd. All of that kind of stuff, that's how the shell works. So we have this new module we're introducing called SHUtil. And what that's going to do is give people that have experience with bash and shells and window PowerShell and that kind of thing, it's going to give you the ability to pull that into Python without knowing the other ways to do it inside of the OS module. So we covered that module in the last class, right? If we take Python 3, right? Let me clear it up. Boop. And I say import OS. I can say help OS. And there's different things in here that we can do. And by the way, that could be too big. Let's pop it up. There we go. So one of the things that we have inside of OS is we should have unlink. Okay, so we have remove and we have unlink, right? You'll find these types of functions inside of OS. These are also inside of SHUtil. This is just, SHUtil is an easier way to do all of this stuff. Marco?
Can I just mention some life experiences with this stuff? Because I dabble in programming and I started with shell stuff.
Right.
By doing little things on the shell. And I just want to mention that for anybody who's new to it, it's fun because when you're programming, that shell command is fun because when you're programming with that, it's really easy to test what you're writing. You just open up a shell and run the command, and then you can just copy that. Once you make that command do what it is that you want, you just copy that into your code, use the shell command that he just showed you, and it's really easy to test. I just wanted to make that comment.
There's certainly a division here between the people who come from programming the natural way and the people who come into programming the academic way, right? This is the academic way. I'm here to teach you tricks of the trade of how to become a programmer. If you didn't do this, a lot of people, myself included, became programmers more out of necessity or because we just were in an environment. If you start off and you're in Windows and you use things like the PowerShell, or you start off in Linux and you have things like the shell, you find yourself doing more and more programming tasks like Marco, right? If you're in QA, that's one of the areas where they have this transitionary period. I've learned how to use a computer and I'm really, really good at it and I can do all this typing stuff. And then you find yourself doing more and more programming tasks. It's not like you do it through the class. So this is a module that is going to help people make that transition, right? So we have import OS, and now we have this new thing, SHUtil, and I can go help SHUtil. And in this, if I look for remove, there should be another one in here. I am quite sure there is, and we'll find it here. Maybe it's called delete file or something like that. There we go. You have things like delete tree, rm tree, right? This is like a shell command. You'll find a lot of these. Unpack archive, this is really simple. So you'll find a lot of these utilities, which, Marco, you've seen this command before? Given the command which.
Oh, yeah.
So this is a very popular Unix command. It tells you essentially, if you want to know where a program is located, you can feed it to which. But all of these here are essentially just commands that we use in shell. So now we're going to see how you can use that module here. Okay. Well, let's get out of that and get into this. Okay, so kicking it off, we say here import shell util and OS. So now we're doing two things, right? OS has some utilities in there that are not any different or wouldn't be any different in the shell because they are exactly what you would do in the shell. In the shell, you have cd. In OS, you have chdir. They leave that alone. So we say import shutil and OS. This is a syntax in Python. We've seen how to import one module. You just say import module. You can actually import more than one. Just use a comma to separate them. So we say here import shell util and OS, and then we say os.chdir, and we give it a path, right? So we're going right into the root. We're going right into the C drive. And now we're using shutil.copy, right? And we give it the first path, which is the first file, and then where we want to copy it to, right? Now you'll see here what it's returning. That's what this syntax is. You can see the font face is different. What it returns is C delicious spam text. So if we want to jump, now here's something else we should point out. This here, jumping into the C drive, doesn't make any difference on that command, right? Doesn't make any difference on that command because we provide two absolute paths. So we say here shutil copy, and we give it an absolute path to a file, and we give it a directory, and it copies this file into this directory. Very simple. You can use that for backing up everything. You have shutil.copy eggs.txt, and we give it a new path. This time it's an exact path, right? It's not a directory. It's an actual fully qualified path with the file name at the end. And now we're actually copying eggs.txt into eggs2.txt, right? So these two syntaxes are slightly different. In the first, we give it a directory. It copies the file to the directory and keeps the name the same. In the second, we give it a directory and a new name, and we get the new named file. Okay? shutil will copy a single file. shutil copy tree will copy an entire folder and every folder and file contained in it. We talked about that earlier, this idea of recursion, right? Computers don't work on trees of files, right? You have to work on that. So how do you do it is you go and you navigate through that tree and do whatever you need. Well, shutil.copy is just like that. It does not recurse. But this new utility called copy tree does, and that makes it a lot easier. Right? So now if you want to copy a directory and you got a bunch of crap in it, including other folders, you can just say copy tree and you get it all. Okay? So enter the following into the interactive shell. Import shutil os, os.chdir, and then we give it this new path, shutil.copy tree, bacon, bacon backup, and what does that do? We have this path here called bacon, and we have a new path called bacon backup, and it has all that stuff in it, right? I would show you a lot of this thing, but it really, I mean, there's nothing much to show, right? You're just essentially doing a copy command. shutil.move, right? So when you copy a file, you're actually making a copy of it. When you move a file, you copy the file and then you delete the original, right? Or you rename the file to a new name. Can be implemented either way. But when you move the file, you lose the original one. No matter what happens, it's no longer there. When you copy a file, it is there. So it takes the same syntax as copy. There's really nothing new or exciting there. Move is move, copy is copy, move loses the original. Okay. If you try to move a file here, right, cbacon.txt to a folder named eggs, move is taking a folder name, right, then you have a problem. And if you can't find the folder, it's going to throw an error, right? So notice what it's doing here. If it has an extension, right, it thinks it's a file. assumes that the destination must be specifying a file name and not a folder. So the bacon text file is renamed to eggs. If you don't have the extension, there you go. Here's what it's doing. In this case, what it's doing is we're simply dropping the extension. That's what they're showing you. So if you move a file, right, you're moving bacon.txt to a new file called eggs. And eggs no longer has the txt extension. So they're telling you there to just essentially be careful with the extensions. In this one, though, they actually take it and they say here, if the folders that make up the destination must already exist, or Python throws the exception. So here what you're doing is you're taking a file, spam.txt, and you're trying to move it into a directory that doesn't exist. And in this case, Python doesn't know what to do and you get an exception, right? Which is the same thing that we saw. And any time you try to open up a file that doesn't exist, that's what you get. Open or write to, file or directory that doesn't exist. Okay. So now we find unlink, right? This is the OS thing. So this is where I say that there's this kind of, there's this intersection here between shutils and OS unlink, right? Shutil and OS, rather. We have this os.unlink. This is essentially going to take a path or a file, either one, and remove it. We have os.rmdir. This only deletes the folder at the path, right? And then we have shutil.rmtree. And what this does is it's going to recurse down and remove everything. A lot of these may seem somewhat like we're just going over these pretty quick. And the real reason why we're doing that is because we're just showing off methods at this point, right? So whereas we had that division, in previous lectures there was a specific concept I was trying to teach. In these lectures there really is no concept, and you're going to see a lot more of that. You're going to see a lot more of learning actual, it's almost like things you could memorize or things you should be introduced to. But they're not conceptually difficult at all. This is just boring administration, and that's why the book is literally called Automate the Boring Stuff, right? So in order to automate the boring stuff, you got to learn some boring stuff. This is some boring stuff. Okay. So we went through this in this last class. Lister, right? Lister is going to show you everything inside of the directory. Does anyone have any questions about any of this stuff? Feel free to raise your hand. If not, I'm going to move quicker because I'm going to assume we got it all figured out. os.lister is going to show you all of the files inside of the directory, right? And what you're going to do is you're going to get a different file name for each one inside, and then we're going to see whether or not it ends with .txt. Notice ends with here. If I was to open that back up, let's go here, boop. If I was to go hello, right, I have a string. If I was to go .hello .ends with, I think this should work. There we go. I put the parentheses on the other line. But what I'm trying to show off here is that ends with, in this case, is just the string. So you got to wrap your head around this idea that this path you get back is not special. So we're testing here, but we're testing as if file name is just a string. So we're making sure that this string that we get back has rxt at the end, .rxt. And .rxt is the extension, right? You could be testing for MP3s or PDFs or TXT files, and that's all you're doing. You're saying, are the last 4 characters .txt? Are they .pdf? What do we have? And if they are, what do? We called unlink, right? Now, we already went over unlink, so we know what it does. If anyone here forgets about what unlink does, what do? You look it up in help, right? So that's real simple. Let's go over that, and I want to show you it one more time so we can just see it. We've already imported OS. You can see it right here at the top. So we can go right to it. We don't have to read through all the crap of OS. We can just go help os.unlink, and boom, we can see exactly what the issue is, right? And I'm going to make that big so we can see it without it folding all over the place. Unlink, remove a file, same as remove, right? And now we get the complex stuff where the book may or may not go into it. If dirfd is not none, it should be a file descriptor open to a directory, and a path should be relative. Path will be relative to that directory. So you can see this here. This is the first thing we're getting, dirfd. That is, let's skip that because I don't want to go into that all the way. I think if the book gets into it, that's fine. But we haven't went into directory handle, so that's probably something I should just leave that out for the time being, and we'll do it over lunch. All right. So, dinner. Is it coming, Marco? Okay. Do you get the emails on that?
Yes.
Aha. Cool. I should also get on that email chain.
Yep.
I am currently amassing the social capital needed to make that investment.
There was a mix-up, and today's order will be all pineapple. Sorry.
Oh, I hope you didn't pull that.
But he hasn't noticed. I kind of say that every week.
Yeah, yeah. One of these days you're going to do it once, and then I'm going to die. All right. So here we go again. We have import OS, right? We're going back. We're importing the operating system module, right? And we're doing the same thing we did before for file name in OSter. We're iterating to each file in OSter. If file name ends with .txt, now this time we've removed the unlink, and we're printing things out first. It's always a good idea to print things out before you start deleting shit. Make sure your script is going to do what you want before you do bad things with it. Okay. Save deletes with the send to trash module. So we have this concept of RM tree, right? RM tree is actually doing things on the file system, right? It's actually a file system based function. It's deleting all of the stuff as if you were writing your own operating system, if you will. There's a Python module called send to trash, and what that does is it simply moves your stuff, right? So I believe the way this module works is it looks for a trash can if your operating system has one and moves all of the crap there, which is nice. If you use Windows, it's a recycling bin. I don't know if Mac has a trash can. It does? It's the original trash can is what we have in the back from Robert. There we go. Yeah, live dangerously and never use this module. That's my advice to you. Like logs, it's totally pointless. No. So we have this thing here, import send to trash. That's all it takes. Now here's what I think. I don't think, see, after you have installed the module, right? So now here, I know how to install the module. Who here remembers how we install a module? This is your Jeopardy question.
What is pip3?
Yes, okay. So what's the command pip3?
Install whatever.
That's exactly right, right? So we introduced this before. We've done it before in the class live, so let's go ahead and do it now. Live, it wasn't horrible to me, which I can't say about everything. So what we're going to do here is I'm going to clean this up, and we're going to go here, pip3, of course, because it's OS X. Yeah?
I use Python 3 space -m space pip space install and then the module name.
That's terrifying. Let's not do that. So I have pip, and pip is Python 3.7. So the lesson here is that OS X calls pip3 if you're on Linux, you know. So yeah, fascinating. Anyway, so sudo pip install send to trash. Or maybe I can just do pip install send to trash. Maybe I don't have to sudo that. Pip install, I could even do user, huh? Send to trash. Let's see if that works. Nope. Okay, so pip install user. There you go. Okay, Python 3, import, let's clean that up. Import send to trash. Voila. Thank you. Thank you. Thank you for that round of applause. I appreciate that. Yes. Okay. So anyway, I'm showing off my Mac OS X skills here. So let's go back to this. Yeah. I'm sorry. Say that one more time. Unlink. Okay. So your file system itself. Think of it like this. It's a good question. Your file system is like. It's like a telephone book where you have a name and you have a number, right? That's how the file system works at the lowest level. So the name that you give it resolves to a number. The computer calls that number an inode. You don't have to know that. Where does it send that file? It doesn't. It simply deletes the entry. So when it deletes that entry, your computer no longer knows where that file is at, and your file system thinks it's free space. So if you have one of those old disks that spins, that you know, were a thing about 10 years ago, if you have one of those and you delete a file, you'll notice it happens instantly, no matter how big that file is, on most file systems. And the reason why it happens instantly is because it's not writing anything. It's literally deleting one line. So that file goes away instantaneously in the file system, but all of that data is still on disk, right? So you can actually pull the disk out and recover it. So where does it go? It doesn't go anywhere. It stays, all of that data stays exactly where it's at. The only difference is the computer no longer knows where it's at. So does that make sense to you? Okay. All right. And that's really cool, because if you have questions like that and you want to know more about file systems or whatever, we can do that kind of stuff too. But send to trash, what is it going to do? Send to trash is going to take that little directory entry and says, this file is stored in this location, and it's simply going to say, nope, I'm not. I'm stored in the recycling bin, right? And that's a little bit more complex than that, but you get the idea. All right. So here we go, and let's go back to this. And I will probably play with this module just because I'm curious to know where the trash can's at in OS X, and that sounds like a blast. So we have this import send to trash, and then we say bacon file open, bacon A. Aha, A. What does that mean? Append. No more from you because they're sleeping. So append means that we're going to create the file, and if the file already exists from the sleeping side of the room, what do? Stop sleeping, sleeping side of the room. Robert. If it doesn't exist, what does it do?
It creates a zero link.
That's right. And if it does exist, what happens?
It starts the file position at the end.
That's right. So if it does exist, you don't clobber it. That's the key. If you open a file for writing, one of the things you're going to learn, and you're going to do this the hard way, no matter how many times I tell you, you're going to say, I want to write to a file. You're going to open it. You're going to give it the right mode of W. You're going to go look in that file, and you're going to say, all of my shit's gone, and all I wanted to do is write a line to it. And the reason why that happens is because write normally, it clobbers the file. That's the word you use. And clobber is every beginner's way of saying, oh shit, I just lost something, right? It's like it's natively negative, and that's the reason. Okay, and I love the fact that I can look back. I expect to see code, and then I'm pleasantly surprised with that beautiful face. This is wonderful.
Please keep it on the code.
I don't blame him. I don't blame him. I would do the same thing. In fact, I'm not even going to bring the HDMI cable next time. All right. So we say here, bacon file.write. We've opened a file for appending. We write bacon is not a vegetable. Now, if that file has other crap in it, we just appended to it. We didn't clobber it, so save the day there. And then it's going to tell us here how many bytes it wrote. It wrote 25. So if you wanted to count these characters, which I won't do, you'll get 25. Then we say baconfile.close, right? So now we're saying we're done writing to the file. And now we're going to send it to the trash, right? So it is gone. Out of there. Okay. So let's do that. And then what I'm going to do is I'm going to ask one of you OS X fellers to tell me where in the hell the trash can's at, because I don't know.
It's many places. Do you want to put something in it or take something out?
I haven't decided yet. Give me a second.
I think it's a hidden directory for user.
Yeah, it's dot.
Oh, that's where he wants it like from the command line?
Unless it's a network search, it's not.
Don't ruin the secret yet. Gosh.
We don't know the question.
Spoiler alert. Okay. Let's take it, and we're going to exit out of that. Oops. Control D. There we go. Okay. PWD. We're in this. I'm going to create this thing called trasher.py. Now I'm going to copy this with Mac, and I'll probably screw this up, but nope, did it. Look at that. 1 point. I've learned copy and paste. And then let's take it and go boop. Okay. So now I created trasher.py, and we're going to go ahead and run it. I don't think that's the way. Yeah, no, it worked. Okay, Python 3, trasher.py. Now, where did it put my bacon.txt? Now you can give me the spoiler.
Home directory.
Home directory.
Dot capital T trash.
Haha,
Oh,
yes.
I didn't even know that.
And then there's my bacon.txt.
I was going to tell him where to go with the
Bacon is not a vegetable. So now we found it.
It might actually show up here. It does, but I know
Okay.
how to get to it.
Very cool. And all of my other work files. Great. Let's go back. let's clear that. Okay. So there we go. And now here's the other thing. If I wanted to, I could take it and we could do proof of point here, and I could open this thing up. I think it's command this. This is how you do everything in OS X. It's their equivalent of an omnibar, and we have movies trash here. I don't. Yeah, where's the? I would. It's at the very bottom of this thing. Is that what it does?
The dock is the thing that pops out.
So this is why I prefer the command line. Where is this thing?
This is Spotlight. If you go to the dock on your left-hand side.
The dock on. So this thing.
Right-hand side part, yeah.
This thing.
The thing that pops up on the very bottom, you'll see a little trash can. To the right.
Ah. Okay. There we go. And then there we go. And then bacon is right there. So that's how everyone else does it. If you want to do the point and click method, and then there's our bacon. Cool. All right, let's close that out. And let's go back. Okay, make it big again. In general, you should always use send to trash, send to trash. That's, of course, not true. You should always risk losing all of your files and do it like RM and unlink, like God intended. Okay. As they say, safety third. Walking a directory tree. Say you want to rename every file in some folder and every file in every subtree of that folder. That is, you want to go through the directory tree, touching each file as you go. Writing a program to do this could get kind of tricky. Fortunately, Python provides a function to handle this process for you. Okay, this is kind of cool. We talked about this need here to recurse in earlier, right? So when you recurse in, you're telling the computer, go into every directory I find, process the folders, if one of those, process the files, rather, and if one of those files is another directory, go inside it and process those. And you keep repeating that process, right? So the process is examine all the files. If one of them is a directory, go inside it and examine all those files. And if any of them are directories, go inside it. And then that's the process of recursion. You have that, file or directory, if directory, go inside and start over. What we do here is we're looking at this tree that we have. And let me see if I can make that small. We're looking at this tree that we have. And what you're going to see is that we have this function called os.walk. And this does all of that for you. So all you have to do when you walk a directory with walk a tree with os.walk is you have to tell Python, when you find a file, do this. That's it. Then you just give it the location of wherever you want to start, and Python does all of that work of recursion, right? So the recursion concept is something we don't teach in this class at all. Right? It's, in fact, I think even in chapter 0, I think they start off with that. They go through the concepts that we will not be covering. Recursion's one of them. And we use this os.walk to totally skirt this, right? So we say here with os.walk, we just say import os, for folder name, subfolders, file name in os.walk, and then here's the base, right? This is where we're going to start that search, and see delicious. So each time we go through this, right, os.walk is going to return one of those tuples. You guys remember the tuples? We covered that earlier. I'll show you that again for those of you that want to recap on that. Here's a tuple. We have A equals, nope. Try that again. A equals, and then let's say here, hello, 1, and then we can even do 4.123. Okay? That's a tuple. Now, if I want to look at A, it tells me there that's what it equals. And here's the catch. We can actually assign that tuple to 3 different variables, right? I could say here, foo bar baz equals A. Now, if I look at all of these types of things, you're going to see that they're set. And we went through this when we covered tuples. That was ages ago at this point. So what I want you to see is that that is exactly all that's happening right here. os.walk is returning a tuple. Inside of that tuple, we have folder name, subfolders, file names, right? And then that's it. So each one of those represents one thing it found. We should expect file name or subfolder or folder name to change each time. You'll never get the same call with all three of those the same. So all you're doing is saying, I want you to take care of all of that work of the file system. I want you to call me when you find something. And when you call me, have these three pieces of information at hand. So then when we do that, it says here the current folder is, and we say folder name. And then we say for subfolder in subfolders, right? Print subfolder of is a string, folder name colon subfolder, right? What are we doing here? Okay, let's go back and let me show you that other example. Okay, so we talked about here how we could have a tuple with three things in it, right? And in this case, all three of those things, string, number, float, all three of those things represent one value. But a tuple could also be this. I could do A equals, right? Now if I go back up and I use the same code I did before, foobar baz equals A, and I look at bar, I see 1, 2, 3. Now this should make sense, right? I could just say for value in bar, right? Print value, and I get my 1, 2, 3 out. So what does that tell us about this, what we're looking at right here? Okay. It tells us right here, this subfolder, this here, subfolders with an S, that this is a list. So os.walk is a tuple with three things in it, a folder name, which we know is a string. We know it's a string because we're concatenating it with another string. And remember what happens when you try to concatenate strings and numbers? You get an error, right? So we know that folder name is a string, and we know that subfolders here is an array. I mean a list, I'm sorry. Python talk. It's a list. And we know it's a list because we can say here for subfolder in subfolders, right? So we can iterate through that too. So we're essentially iterating through each different thing OS walk returns, and then we're iterating inside of that for each different subfolder in the array that OS walk returns. Okay? Now we have here for file name in file names, right? Print file inside, folder name, file name, and then we print the empty string. Okay, this is the same thing, right? So folder name is a string, subfolder, right, is an array or list, file names is a list. Yes?
Earlier when you were talking about what OS walk does, it sounded like you were saying that it traversed the entire directory tree and then returned. Is that the case, or does it return like an iterator?
It returns an iterator.
So it doesn't traverse the entire directory tree in the beginning before doing anything.
Exactly.
It will give you one file at a time.
That is exactly right. Yep, it's an iterator. Almost everything in Python is an iterator. It's almost that's an important distinction. Do you know other programming languages? What do you come from? If you don't mind me asking, you have a predominant one?
Lately it's been C#.
I see. So
There it's an iterator.
sure, right. So in Python, unless you explicitly cast a generator to a list, everything is a generator or an iterator.
Except for the range function, right?
Nope, even that.
I
You
think
won't.
we use xrange in our beginning.
Nope. I mean, maybe in Python too, but in
Oh,
Python,
Python 3.
right. So if I say here like range, let me show you what he's talking about. He's saying here, if I say range 5, right, I get this thing range 0 to 5. That is a generator technically. If I want to get the numbers 0 through 5, I actually say list range 5. Right? Now I get the list. So he's asking about the distinction here between actually having a list and having a generator. Now what's kind of cool is, and we're not going to cover this in too much detail, but I am going to cover it just briefly because it is kind of nice to know it. When we showed that code, right, and I'm going to show you this here, because sometimes we can make questions which are more advanced, a learning opportunity for everyone. We see here OS walk, right? Now think about when you're implementing OS Walk. We will not be implementing OS Walk. There's two ways we can do it. One way we can do it is we can say, I want to do all of my work now. And then when I'm done with my work, I want to give you the result of my work, right? Now, that makes sense because it's a clean division of tasks, right? Cleanly, I'm done, you start. The problem with that is if you have a directory and it has 100 million files in it, you have to do a lot of work because you're going to have to go through each one of those files and say, are you a directory? Should I go inside? Are you a directory? Should I go inside? You could be there for a while waiting for os.walk to finish if you implemented it that way. The other way you could implement os.walk is to say, give me one file, then I'll do my work. Then you give me another file, then I'll do my work. And that way you're balancing your work out and you're not needing os.walk to do all of that work at the beginning, right? So os.walk is technically an iterator. It's going to give you something back that allows you to grab its work and then tell it, I want you to do more work and give me something else. And all of that happens under the hood. All right. I feel like that's a really shitty introduction to iterators, but we're not going to touch that in this class beyond it. So moving on. We have, so here, os.walk function has passed a single string value, the path of a folder. You can use os.walk in a for loop statement to walk a directory tree, much like you can use the range function, there you go, the exact one, to walk over a range of numbers. Unlike range, the os.walk function will return 3 values on each iteration of the loop, right? So what they're saying, 3 values, is right here, folder names, subfolders, and file names. It's actually returning that tuple that we showed earlier. And I tried to show you how that worked, because that's something that I think I can help make the book clearer on. A string of the current folder's name, a list of strings of the folders in the current folder, and a list of strings of the files in the current folder, right? So os.walk is going to return once for each folder with all of that stuff in it. Just like you can choose the variable name I in the code I range to 10, we already seen that. Moving down. Okay. So you can see here how it runs, right? When you run this program, it'll output the following. The current folder is C Delicious, subfolder of C Delicious is cat, subfolder of C Delicious is walnut, file inside spam. Right, now you can see here it's moving, and now it's inside of cats. So before it was telling us inside of delicious we have the subfolder cats, but now it's telling us the current folder is cats, right? So you can see os.walk did something. It changed directories from delicious into delicious cats, right? And then what does it find? It says file inside. Yeah, I'm not going to touch that one. File inside. File inside. C Delicious Cats, cat name, and Zophie. They are gone. The current folder is C Delicious Walnut. So now you can see here, let's go up. What we did is we had a directory. We gave it C Delicious. Inside of that, we had 2 different subfolders, cats and walnuts. We actually went and crawled through cats here, and we crawled through walnuts here. See how that works? And then we find this other one. Inside of walnuts, we have another directory called waffles, so we go into that. So each time, walk is going into a different folder and telling you more about it and its contents. Okay. Returns the strings upon the variables. You can list these with their own for loops. So this with your own custom code. Okay, yeah, I'm not doing that. Compressing files with a zip file module. Okay. So before we touch the zip file module, let's go ahead and break for pizza because they're here. I hope everyone is eating the non-pineapple pizza. If you like pineapple, then I'll be nice. I'll let you off easy this time. All right, welcome back. I hope you all enjoyed lunch, unless you were eating pineapple pizza, in which case, you know my sentiments. I hope you're no longer with us. Okay, so we just now finished up doing this idea of walking through directories, and essentially what we're doing in that is we're telling Python, give me a heads up when you find a new directory, and when you find a directory, tell me all of the subdirectories that are inside of it, all the files that are inside of it, and where the hell you're at. And then Python takes care Python takes care of all the gory work. It just gives you the heads up and calls your code. So now what we're going to be doing stuff with zip files, right? So you can see here right off the top that we're going to be using the zip file module, which means installing the zip file module, right? So I'm going to do this, and we're going to go back over it. Boop. So to install a module, I'm going to use pip. Now, if you're using Linux, you may find that as pip3. If you don't know whether or not you're using Python 2 or Python 3, heads up, you should always figure this out, because some systems install both, and you don't want to be programming with the wrong language. If you type in -- version, generally speaking, no matter what you're working with, it will tell you the version that you're working with, right? So here you see at the very bottom, Python 3.7. That means I'm using pip. Pip is using Python 3.7. That is the same thing as pip3. OS X just drops a 3. Okay, so we want to install the zip file thing. So we're going to do pip install -- user and then zip file. That's it. Could not find a version that satisfies the requirement of zip file from versions. No matching distribution found for zip file. Oh, shit. Yeah, bleep that one out. You can download this zip file from, okay, we have that. Okay, that I wasn't expecting. Hold on a second. Import zip file. Aha! It doesn't have to be downloaded. It's a module that ships with Python. Okay, so we learned something, because we always learn stuff when we make mistakes. The zip file module, unlike the paperclip module and unlike the other module which we just installed, right, does not have to be installed. It comes with Python, so we don't have to do anything. The other module we just installed was trash to delete file to remove to trash. Remove to trash. The remove to trash module we had to install. The paperclip module, we made the clipboard modification we had to install. This we don't have to install. It's like OS. It's just more specific. Okay, so we can go into Python 3. And I can say import zip file, and it works. And I can say help zip file. And what that will tell me is everything about zip files. So if you want to become an expert in zip files, this is how you do it, right? A lot of this stuff is way beyond the scope of what we're going to be doing today, but we may go back to it. So come back over here, and you'll see what we're doing. First step we're going to be doing is reading a zip file, right? Now, you go up here, and a quick shout out. They have an archive online for this thing where they have all of the code and all of the code samples. And if you don't have that on your computer, you may want to get it, right? And it has made my life a lot easier ever since I stopped live coding and I just used their code. Because live coding is less fun than it looks, and I know it looks painful. So the thing here is you can grab that code online, and if you grab that code online, what we're going to be doing is looking inside for this thing called example.zip, right? So having grabbed it online, what I'm going to do is come back. We're going to get out of that, and I'm going to go here to downloads, pwd, nope, downloads. By the way, the ... means I'm going up a directory. We learned that in the last class, right? That's the computer language for up. And we're going to go into downloads, and then I'm going to look for this automate the boring stuff with Python materials, which they call that. Now, if I want to clear all that crap and move my cursor up to the top, I just hit clear, and boom, we're up at the top. And now I can see what we have inside, right? So you'll see here what we have in store for us. We're doing some stuff with PDFs later on. We're doing some stuff with spreadsheets later on. You'll see all that stuff in future classes. But what we're looking for today is example.zip, right there. And you will see it. Example, there we go. dot zip. Okay. Why is that weird? Oh, there it is. Okay, I'm not seeing it. That's how it's showing. It's just big. Okay. We're going to be opening that file up and taking a look at it. So let's go back here. Big. Come down, reading zip files, and here's our code. Let's go through the code. So right off the top, we're importing zip file, which is that new module that we already have. It's part of core Python. We're importing zip file. We're importing a file, the module OS. We've seen that before. That's the one that provides that path name feature where we can do the relative and absolute path names. We are jumping into the directory C drive. We will not be doing that in ours, but you see on the right-hand side, that thing that starts with a pound sign, that is our comment. We don't process that. It's just a note to us, programmers. He's moving into the folder with zip. Okay, so my folder is not C drive because I'm not using Windows. I'm using OS X, which is worse. And I'm going to take it and I find example zip. And in order to do that, I use zipfile.zipfile, and I give it example.zip, right? So this feature here, we have a module zip file. And in that module zip file, we have a method zip file. Now, the astute will notice that the Z's are different. They have different caps. That is by intent, right? Modules are always lowercase in Python. Method names are sometimes lowercase, but not always. So this guy is always going to be lowercase, even if all of the marketing spiel and gobbledygook is uppercase. Usually, that's the way it tends to be with Python, or so I see. So what we're doing here is we're saying, I want to create a new zip file, example.zip, or open a zip file. Then what I'm doing is I'm saying name list. What is name list returning? It's returning spam.txt, cats, cats, and cat. Something other with cats. Notice no bacon. The author's diversifying. I like it. Spam info. Now we're saying example.zip, get info, spam.txt, and what is it telling you? So we have let's go through some objects here, right? This zipfile.zip file, right? This is taking an argument, example.zip, right? And it's returning something. This thing it's returning is an object, right? How do we know it's an object? That's a good answer, but it's also a smart-ass answer. We know it's an object, and we like smart-ass answers because they're usually more correct than no answer, which is everyone else. So what we have here is example.zip, and example.zip we're calling a method, name list, right? So you can't call a method on something that's not an object. So example.zip has to be an object, right? So we know when we call a zip file, we're getting back an object that represents the zip file. Now, what does that look like? That looks like how we did the file system earlier, right? We call open, we get a file object back. On that file object, we can call read and write, okay? So example zip in this case is just like a file object. The only difference is it's a zip object, right? So you call open, you get a file object. You call from the zip file this method called zip file, right? And you get back a zip object. That's your pattern. I want you to see the pattern because there's really not much shit we can take away from this boring stuff. So if we got to know that pattern so we can start making sense of things. Randy?
What is an object?
It's a good question.
An object has data and the thing that defines the data, right? What is that other word?
Sure. So here's what an object is, right? For the purposes of this, and by the way, we can be somewhat satisfied that I won't be overly corrected on this because the real question is, how do you need to think of objects at this stage? Not where would you be thinking of objects if you had a PhD in computer science. What you need to think of is an object, right? An object holds something inside of it, and that thing that it holds inside of it is important. We call that state, and it can be anything. For your purposes, it's just data. It's a fancy way of saying data. The difference between those two words is the object holds it inside. So there's something special about that, right? When we call zipfile.zipfile, we're giving it example.zip, and it's never forgetting it. That's what you're constructing this thing with. It has this as an argument. That is part of who it is, right? And the object component is that you have this stuff that makes the object, which is this state, this data that we're using to build it. And then the object itself can do things, right? So it can do something. And those things that it can do, you get out of that object by calling a method, right? So in the object-oriented paradigm, you say, I need to make a dog. What's the dog's name? What's the breed of the dog? Now you've got a dog. Now what can the dog do? It can bark, it can run, it can move, all of those types of things. That's your traditional canonical concept of an object, right? Most of the time, when we teach object-oriented programming, we use animals because they're also hierarchical, and that makes sense. But we're not getting into any of that with this. We're keeping it very simple. We're creating an object that represents a zip file, right? And with that object, we can do specific things. Right now, one of those things we need to do with that object is get a list of all of the contents inside of it. And we do that with this method named nameList. Okay? So we say example zip.namelist, and it's going to tell us all of these different things that are inside that zip file. That's one of the things that the programmers who wrote zip file did for us. They taught our zip file how to tell you everything it has inside of it. And all you got to do is say namelist, and it knows how to do the rest of it. And that's kind of how this object-oriented paradigm works. So we say we want to get that name list, right? And it's going to give it to us. And we have this other thing now, right? Where we have getInfo, right? So when we call getInfo, we give it the element from the name list that we want more information on. And it's going to return spam info. So let's go up here and rephrase. We constructed a zip file object using this. We got our zip file object and we called namelist on it. Now we're introduced to a new thing called getInfo, and we give it an argument, this spam.txt, and it returns what is essentially what we would call, these things inside of the zip, these files inside of the archive, it's an object that represents that, spam info. Spam info is the file inside of the archive that represents spam.txt. And then from that point, we can say file size, and it's going to tell us what it is. We can say compressed size, and it's going to tell us what it is. So we have different objects here. We have the object that represents the archive, example zip, and then we have the object that represents the file inside of the archive, right? And these have, we call these attributes. Notice there's no parentheses on this one, and we call these methods. There is a parentheses on that one. Okay? So, and let's go back to that online help thing. Let's take a look at that. So we have kind of slowed down on live coding because we had some rough spots with it. And live docking has also given us some rough spots. But let's give it a shot. Help, zip file. Because I want to show you how we read this, right? So we have this zip file object is what it's telling us right here, built-in objects. This is what I was talking about. And notice, I never read the docs for this thing. I didn't even know this was a core module. I just look at the syntax, and I see the patterns, and right away these things come apparent to me. And it's one of those things that it's relatively important that we learn those things. Making sure this is on. Okay, so we have here the zip file object and the zip info object, right? Those are those two objects that I just picked out, and I said we can identify them, and I showed you how. Here's our zip file object. We create it by calling zipfile.zipfile. There's the zip file object. We're saving it to example zip. Here we create a zip info object. How do we do it? We do it by zipfile.getInfo, and then here spam info is our zip info object, right? This may be a little bit more complex, but the only value that I can add to you over just simply reading the book and going through these things is if I kind of try to bring some of it to the table. So if you have any questions, just ask me. But this is definitely more thorough than what the book is showing you, right? Okay, so let's go down here and we're going to look at some of the other stuff that we have. And I'm going to see if any of it is useful. And this is what I normally do when I get an object, when I get something like this that I want to interact with. If I want to do something with a zip, I'm going to open up the help pages with it, and I'm going to start going through it. Right? Now, I know I don't care about the bad zip file stuff because we don't give it bad zip files, right? Large zip files, probably not going to be using that one either, but maybe. Py zip file, there we go. Class that creates zip archives with Python library and packages, that may be useful. So here's some of the things that we can do here with zip files. We can call extract on a zip file, right? Now notice what we're expecting here. We give it a path on extract, right? We also have extract all. So extract all takes the same syntax. It extracts all members from the archive to the current working directory. Path specifies a different directory to extract to. Members is optional and must be a subset of list returned. So let's parse that. Path is going to be where we're going to send it to, and members doesn't have to be defined at all. Defaults to none, right? With extract, see how we have this thing in the middle, member? That means extract is taking a single file. It's going to get us a single file. They call this file a member, right? These aren't my words, they're their words. So we just accept it, and we don't redefine it. Extract all doesn't have the member thing. It defaults to none, and that's because it's going to give you all of the shit in the zip file, right? So if you want the GUI analog, when you have a zip file on your computer and you double click it, and it dumps all that crap all over your desktop, that's that guy using extract all. And if you've ever seen the GUIs where you can like open the zip drive intelligently, by the way, Mac OS doesn't have this. Linux does it by default. Just telling you how much simpler it is, even though people don't believe me. And if you know how to do this with a Mac, you tell me, because I couldn't figure it out and I spent a day. Extract, you open up the zip file, you find the zip you want in the zip file, and you can just select the one file and drop. So you would write something like that functionality with extract. And extract all is what Mac does, where you double click it and it craps all over the place. So we have this thing nameless. We've already seen that. That's going to tell us all of the items inside of the zip file, right? We have set password. That sounds like fun. I don't know how effective it is, but why not password everything? It'll make you look important. And then we have test zip. So if maybe you have a corrupt zip file and you want to know where the corruption's at, maybe grandma sent you one that's a little foobarred, you can figure it out with that. So this is how you kind of do it. You kind of go in there and you say to yourself, and I'm going through this because people, they say, how do we structure a program? You're working with a zip file. This is your module. Go through it and see what you can find. And if you can't find what you need, right, go to Stack Overflow and ask someone smarter. That's what I do. Okay. So going back. We get the file size. We have this spam info object, which is representing a member. We now know the name of it, right? So we have a member inside of this archive called spam.txt, and we're calling file size and compress size on it. And then we say compress file is what percentage smaller, right? And then we use this. We say round, okay. We say round, and I want you to see this is rounding, and this is the argument to it right here is the 2, right? So we call round, and we take this spam info dot file size divided by the compress size, right? So we take the file size on the top, right, which is the original number, the bigger number, and the compress size on the bottom, which is the smaller number, divide it out, and then we want to round it to 2 digits, and we get 3.63 times smaller. So this is going to go through a zip file. It's going to tell you how big, what the compression ratio is of spam.txt. Okay. Extracting from zip files. Import zip file in OS. We already see what that does. We're going into the root directory, C drive. We're saying here example zip equals zip file.zipfile example zip. That sounds really redundant, and it is, but module method, argument, zip file object. Zip file object, method, extract all, right? Crap all over the desktop like Mac OS. Example zip, dot close, and parentheses. It's done. It did its job. Think different. Okay. After running this code, the contents of example zip will be extracted. Oh, I have this thing up here. Reverb. I don't know what that is. After running this code, the contents of the example zip will be extracted to C drive. Optionally, you can pass a folder name to extract all to have it extract all the files into a folder other than the current working directory. That's not all that much better in my opinion, but yes, it will crap somewhere at least else. If the folder passed to the extract all method does not exist, it will be created. Okay, so that's really cool, you know. And yeah, so that's slightly more sane. So now you can say example zip.extract all, and you give it where you want to dump that stuff to, right? So you say, I need a zip file object that represents the zip file. Now you're going to just say dump that zip file in this location. And then there you can see the example of it. No, this is something totally different. Okay, so moving on, the next piece of code we have, example dip.extract. And in this case, we're saying what we want, spam.txt. Now that's kind of cool, right? So now we can say if you have, let's say you have 1,000 zip drives, and you want to get 1,000 zip files. You want to get one file out of each one of those 1,000 zip files, right? On OS X, you'd have to go, let me just tell you how bad it would be. You'd have to go through each one of those 1,000 zip files and have them crap over the current directory you're in. You'd have to take the file you want out of that directory. You'd have to delete all of the other files in that directory, rename the one you wanted, and then move to the next one so it could crap all over the directory, rename that one, delete all the other files it did, and you have to produce that thing every time. This is why automate the boring stuff is really cool, right? Because that's pretty simple. I said it in one sentence. You have 1,000 zip files. You want to extract the same file from each one. Ideal computer program. We're doing it here. This assumes that we've already gotten the zip file, right? But we just call zip file.extract, and we tell it which one, and it extracts it there, right? Now, if we wanted to rename it, we could do that. How would we do that? We would use that shell module we saw earlier, and we'd call rename on it, right? Because that shell module is the one that provided rename. So we went through that, and we went through the difference between move and rename, or move and copy. Move is what they call it, right? I said explicitly, move deletes the original, puts it in the new place. Copy gives you two different copies. So if you wanted to just copy that file out or move that file out, you could do that using those other modules we learned about earlier, the OS module and that shell module. Okay. So when we're done with it, we say close, and we move on to the next task. And where are we on time? We're halfway through this thing, and we are 2/3 of the way through the class. Great.
Evan, is there a reason why is your screen too small on your MacBook Pro? Is you're gesturing with the screen like never before, like a lot more than you were before? Like in other words, instead of showing it on the computer and highlighting things, you're going to the computer. You have a whole.
You got me all excited when you showed my face up there, and I keep looking back to just,
Well,
I know this is going to show code, but.
Yeah. I was showing you the program out for a little while, but somebody said every once in a while you're full screen with just you.
Right.
And somebody said, we want to just see the code, so I'm giving you an auxiliary feed right now. I'm going back to the auxiliary feed.
I see. So do you want me to do more of it on the computer or more of it in the hand gesture?
It would look better on the video, but do whatever you want. It would look better. Well, anybody.
Are you telling me I'm ugly? Is that what you just said?
When
You done had a brownie point. You just threw it back at me.
Well, no, you have plenty of screen time, trust me. But when you're selecting something with the mouse, and you're saying, look at this, and you highlight things with the mouse.
Right.
That's very clear. And it's
Okay.
clear in the class, and it's clear in the video.
Okay. I'll keep doing that.
When you're backlit and you stand in front of the screen, you're pointing at something, it's okay, but
I gotcha.
it's not as cool.
All right. Okay. Well, we'll do that. That's a good point. And
Do
yeah.
whatever you want. I can roll with a bunch of.
Okay.
Back and forth. That was more interesting.
I can't. They have me literally on a dog chain now.
That's why they did.
What do I do with this, It's a hard life, I'm telling you. Okay. They tethered me, that's right. Okay. And they say it when you do public speaking, they say, control take control of the podium or something like that and walk. And now here it's like, nope, forget that shit. You have 3 feet or you're out of here. Okay. We have here import zip file, right? So we're taking a zip file and we say essentially here new zip, right? New zip is an object. We're saying zip file, give me an object. What is that thing that keeps someone get me after class and tell me what I'm doing to get that crap up. That's mousy. Okay, zip file, we're giving it new zip and we give it this W, right? So we're going to write a zip file this time. What this is going to represent. How is that useful?
It's trying to help.
How is that useful? No results. Someone tell me how they thought different on that one. Well, it's what? I know. I have no idea who thought that was a good idea, but whatever. Okay. So right here we have new zip dot motherfucker. New zip dot write, right? And new zip dot write is taking the member name, right? This is something else. It's a file in our directory, right? And what we're doing is we're telling it how we want to compress that, right? So in this case, we're using this thing called zip deflated. This is one possible compression scheme. We're not going to go into what that means, but essentially there's different ways to make files smaller, and deflate is one of them. And then after we add spam.txt to the zip file, we say new zip.close, and we have our zip file that we can send to our grandma. Okay. Project. Renaming files with the American style dates to European style dates. Okay. Now I will tell you this right now as a programmer. It doesn't matter which one of these you choose. If you choose either one, you're horrible, right? Programmers always write dates without exception, year, dash, month, dash, day. You will, what? For sorting. That's exactly right. I was going to say that. So what we do is, why do we sort that way? Because when you sort with a computer with English collation, that means in America land place, what we do is we look here at the leftmost thing, right? And we say, is this bigger than whatever else we're comparing it against? We look at the left character. Are they both A's? If they are, go to the second character. Is one of them an A and one of them a B? If so, the A comes. That's how we do sorting. Okay, so when we have here the European style dates, the American dates, we do month, day, year. If it is the, what the hell day? It doesn't tell me, does it? There it goes, March 27th. It's March 27th, so we would have 03-27-R year. But in Europe land place, they do 27-03-year. And they're both really crappy for a computer programmer. So we fixed, and when I say that, this is not like opinion, but most of my stuff is opinion. Some people really think Macs are better. But when it comes to dates, we have an actual standard for it. So there's a difference, right? That's not just Evan saying it. We have an actual standard where we have said, write dates this way or you're insane. And most of the world follows it. But most of the bosses don't. So that's where you work with that, you know? Okay. So the name of this, and by the way, this is also, okay, I now know what highlighting it does. It's a dictionary. That's better than no results. Okay. When we have these dates in this format, this is the one our bosses are giving us in America, right? We're going to convert them to the European style dates. Okay. So we're going to create a regex that can identify the text patterns of American style dates. We're going to call os.lister to find all of the files in the current working directory. We're going to loop over each file name using the regex to check whether it has a date. And if it has a date, we're going to call shutil.move, and we just mentioned that, right? That's the function we learned earlier. Now, here's the thing about regexes, to keep them simple. You will almost always be wrong when you use a regex, right? And I don't mean that to be a smartass. I mean to say regexes are principally to get a job done, and very seldom are they all-inclusive. So you don't want to be the guy that's like, there's an exception here with the regex, because I guarantee you the one we're using isn't right. So when you look at something like that, just know it. There's usually flaws, but it's just good enough, right? So here, we're taking a regex, and you can see here what we're doing. We are, and I'm going to explain this to you because for those that aren't acclimated with this, it'll help. We import shutil, os, and re. Re is the regex module. Really, for re, the only thing that you will need to know off the top of your head, or that you will use all the time, is re.compile, right? So it's cute that I know what it does, but it's not all that useful. re.compile, and that's that dictionary thing that keeps popping up in me. So we take re.compile, and we're going to give it a raw string that represents the regex, right? So R creates a raw string. What does this do? This makes it easier so you don't have to escape everything, right? It's essentially saying there are no variables inside this string. So all of this stuff, right, that's inside of this raw string is part of that regex, right? So let me tell you something else here. Normally a raw string is done with 1 quote mark. If you look here, you'll see it's done with 3 quote marks. The book doesn't say this here, but it made mention of it earlier. 3 quote marks in Python is a special thing. If you come from another language, you don't have this. But this is actually one of the cooler features of Python. one of the areas where it improved, and I actually like it a lot, and I wish Perl had it. You can do 3 quotes, string, hello world, and you can do it like that. And now look, right, I'm going to show you. We constructed a string up here. Right, we talked about this before. If I do this, 1, 2, 3, I'm constructing a list. If I do this, foo, true, nope. Capitalize it, I'm constructing a dictionary, right? If I do this, I'm constructing a tuple. The reason why I want you to get used to that term, I'm building something, right? So if I want to build a number, I just type in the number and it knows what it is. If I want to build a string though, right, I have to use quotes, right? So I have to say something like this, hello, or I have to say something like this. These are all different ways to build a string. But in Python, there's another way to build a string. We can use a triple quote and we can say hello, right? Now, triple quote gives us an advantage. Notice how each time we're building the same string, right? But the triple quote gives us one advantage. Anyone know what it is? What's up? Multiple lines. That's a really good one. What's one more advantage? Watch this, okay? If I do this, hello.
You can put funny characters in.
Well, you can put funny characters in the other ones too. That's going to blow your world. Hello, world. Right, like this. Now, what do you see? I put both a single character and a double quote character inside of that string. I don't have to worry about it. So for you to screw this one up, right, for your user to screw this kind of stuff up, they have to put 3 quotes inside of their shit, or you don't have to worry about it. That's not something you typically find unless the person you're working with is malicious, right? And if the person you're working with is malicious, it becomes a security issue, right? So this is kind of easier because you don't generally have to worry about 3 quote sequences ever. It may happen, but that's what I like about it, right? So what we're doing here is let's cover different things. First thing, yes, okay. So the first thing is, it is the only form that accepts multiple lines. If we do this though, our triple quote, we're creating a raw string here that we can span multiple lines all the way down to here, right? And inside of that, we can actually use single and double quotes. So that's what we're doing. I just want to be sure that we know that the triple quotes here and the R, this is not part of the regex, right? Okay, so this is where the regex,
There are no quotes inside.
I'm sorry, I'm going to, that's the,
Accessibility options, turn it off.
I don't know.
is that under access? Hold on. Someone teach my Mac how to not be a Mac.
I've never had that happen before.
Sorry, trackpad options.
What, track,
First open system preferences.
okay, trackpad.
No, go into the
Sure.
Accessibility?
No,
Trackpad? Okay.
it's
Trackpad, you know.
point and click on the top. And then it's the top one, look up data detectors.
Okay. Cool. Force clicking. There we go. I love that. Let me. That's wonderful. It's sane again. Okay. Great. So here. So let's get back to explaining this regex, and then we can later bliss about how my Mac is now acting, normal. We start here with a beginning character, right? This is what this is. It literally tells the regex, start at the beginning of the string, right? That's what the caret means, right? So we're saying start at the beginning of our string, and then what I want to do is I want to get all of the text before the date. So we went through this and we talked about it briefly. Ed covered the class on regexes. We had this question mark here. This question mark means not greedy, right? So the question mark means we're going to start copying characters. We're going to take characters one at a time, right, until we match the rest of this stuff that we have here, right? So take one character, do I match this stuff? If not, take another character, do I match this stuff? If not, keep going. Until we get to the end and we can't match that shit, and then we fail. So what we do here is we start, and what are we looking for, right? Let's look at this regex. This is part of it, right? We're looking for a 0 or a 1, and we need to have 0 or 1 of them. At most 1, right? And then we have to have one more digit. So right here, this is how they're saying it. 1 or 2 digits for the month, right? Now we have 1, 2, or 3 digits for the day. How do we do that? Right here. We have 0, 1, 2, 3, question mark. Why do we stop at 3? Because no months have 40 days, right? So this isn't perfect because no months technically have 39 days either, but our regex will accept that. But we say 40 days would be insane. And that's kind of how regexes by and large work. You can do later verification later. It's totally fine to not have it all in the regex. So the first digit of the month, right, has got to be the first digit of the day, 0, 1, 2, or 3. Then we look for one more digit, right? Then we're coming down here and we're looking for anything in the 19th or 20th century. Notice we're leaving out the 18th, 17th, and all the other shit. So we say start with 19 or 20 and then look for 2 more digits right here, right? And then we say everything else at the end. So we have this, which is matching the beginning, right up here, this thing. This says everything at the beginning until we start matching all of this stuff right here. And then after we have matched all of this stuff, I want to capture everything else at the end, right? And then you can see what he has later he wants to do. Loop over the files in the working directory, skip files without a date, get the different parts of the file name, form the European style file name, get the full and absolute paths, rename the files. And that's, by the way, not a bad idea. When you're scaffolding, we call this scaffolding. You're scaffolding out a program. You can write about your program flow like this, right? You know, and some people even do this, to do. I've seen professional programmers that literally scaffold all their stuff out with to do. Okay. From this chapter, you know that shutil.move is what we're going to use to rename this stuff. Okay, easy enough. Okay, so you can see here what we're doing is we're looking for dates like this. Spam 4/4/1984, right? This is month, day, year. And something like this, month, day, year, eggs.zip, right? Should be renamed, while file names like littlebrother.epub can be ignored. Why are they ignored? They're ignored because if we come up here and we never match this middle part of the pattern, which we require, then this is never filled out and we're just going to skip it, right? There'll be a line in there that says something like, if you don't match, just jump to the next file. You can use a regular expression to identify this pattern, which we just showed. We use re.compile to create the regular expression. We pass re.verbose for the second argument, and it allows white space and comments in the regex string to make it more readable. Let's go up and let me show you what they're talking about. We have this thing, this triple quote piece here, this raw string. This allows us to have new lines in here, but these new lines are still there, right? So let me come down here, and let me show you what we're doing here. Oh. Okay. We have here, if I say here, let's just show you here, R. If I hit enter right now, what are you going to see? Anyone want to take a guess? It's going to show you what it's displaying, right? So what it's got here is the raw string up at the top that we're creating has captured a new line at the beginning. Why? Because notice how the regex over here on this side, look at this. And by the way, I am both using my hands and my cursor. I want everyone to notice that. Thank you. Thank you. Okay. So no one can yell at me. The raw string up here that we're creating, right? We do not have a new line on this one, right? We literally start it right off with a caret. But over here in Everland place, we jump right down and we say hello, world, but mostly HLUG, right? So because we have nothing here, we have a new line. Because we have to tell the computer, we hit return, return puts everything down. That return is a character like all others. And that character is the new line. We went through this before. I just want to make sure everyone remembers it. So we have a return here, hello, and then we have another return. And then I jammed on space a couple of times, and I put world. And then we have another return, and I had jammed on space a couple more times, and I said, but mostly HLUG. Okay. So we have new line, new line, new line, but mostly HLUG. If we come over here, right, to this code, whoop, we take a look at this code. We see here they have this, right? What else do they have? Aha, trick question. No. They have a comment, right? Now after the comment, what do they have? There you go. I let you redeem yourself. So yeah, we have here, we're creating a raw string, right? We're starting off with a caret, which says the regex starts now, and it starts at the beginning of the string. We're matching this crap. Then we have a space. The space is not significant. Doesn't matter. And then we have a pound sign, meaning this is a comment. And then we go through and we have all of this shit right here. None of that matters to the regex. You can delete it. Then we have a new line somewhere over here because we're jumping back over here. We have spaces. Look at all this stuff right here, right? They don't matter. It's not part of the regex. It's not in the date. Then we have, at the end, we have, this is our 1 or 2 digits for the month. We have the dash, right? Because we do month, dash day, dash year. So this is that dash. We have all these spaces here. We have another pound representing a comment and all this crap that we don't need to have. And then we have another new line at the end. So you can see all of this stuff that is not part of the regex, the new line and the comments, something has to get rid of it, right? And that's what this guy does right here, re.verbose. re.verbose is something you can pass to regex.compile, and it says, clean this up. You're going to get a string with all this crap in it, but clean it up. Let me show you what that string looks like. I'm going to copy this, right? And by the way, one thing I hate about this book is the fact that I think these 3s are actually characters. Let's try this. I'm copying that string, right? Now you can notice this is just the string. This is not the regex, right? Now what I'm going to do is I'm going to get out of my full screen mode. Boop. I'm going to, let's try pasting it. Did that work? It did. Okay, so I take that back. The thing does not copy it. What I want to show you here is this. This is exactly what I wanted to show. When I paste this stuff, this is exactly what I just copied from the book, right? And I hit enter, I get all of this stuff right here. Do you see that? So this is where I stopped, and let me highlight the lines before someone gets on to me about this. Okay, I highlight the lines, and what I see here is that all of this stuff down here, this is what we're passing to regex compile, right? So if I wanted to get rid of that R, that raw string thing, I could type in all of this exactly like that with these new lines, right? I could type that in manually, and I could send that to regex compile and it would work, so long as I use re.verbose. Does that kind of make sense to you? Did I lose anyone in that? Okay, I'm trying to show that we have new lines and they're actually in this string. That's what R is returning. And we can provide this as a regex right here. We can provide this as an input to regex.compile if we have re.verbose. So that's what re.verbose is doing. Okay.
Question,
Yes?
the 4 spaces, is that just because this is a program, that Python programmer writing it that wants new Python programmers to recognize 4 spaces?
The spaces are their style.
Yeah.
That's exactly right. He's just doing that for style. Yes. So the question was, do the spaces here actually matter? And the answer is no, they do not matter. Because when you start a raw string, right, let's show you both of them here so we can actually see it. Because learning how to play and to relearn this stuff when you forget it is highly important. If I say this, R, and I say hello, world, that will work. But I could also do this, R, hello, 4 spaces, world, and that also works. So the first time I have no spaces in this line, right? There's no spaces here. And the second time when I put the spaces in here, I got them here. The answer to your question is the raw string piece doesn't care. Python formatting doesn't care. And re.verbose is going to fix it if you do it.
It's a coincidence that the 4 spaces coincides with the normal indent convention.
Exactly. That's exactly right. Good. I'm glad to know we have people following that 100%. Okay. So We now know how that regex works. And I think in this book they teach you how to think about regexes, which is the only reason why I'm not going to cover that slightly more. Dun dun dun. Identify the, there, okay, speak of the devil. Identify the parts of the regex, right? So we just matched all of these different things, and I told you what they were, like a way to think about them. Well, here's where we actually, after we match the regex, notice we have here for Amer file name, that's the American file name from our bosses, in the directory that we have, we're going to do date pattern.search, right? So we have this thing. Let's go up here. Notice, we are saving this regex as date pattern, okay? So the re.compile takes that big, long, ugly string, and it returns a regex object, right? We can refer to that regex object from then on with just date pattern. So the book is going to just drop this out of subsequent examples. We're not going to keep seeing it, right? So when you come down here to this, you'll notice he says snip, right? That means there's stuff in there that he's no longer showing you, okay? So let's look down there and find out what he's not showing us. If we see right here, date pattern.search, he doesn't define date pattern anywhere. That's because he snipped it out. That is that big regex we just saw. So we do date pattern, which is that regex object, right? Dot search, and then we give it a mer file name. That's our file name. And what do we get back, right? We get back an object representing that what it found, right? And we say, if what it found is none, continue. Okay, this is that part that I was just talking about. When we looked at those different example file names and we said, if you see a file like this, do something. If you see a file like this, do something. But if you see other types of files, skip it. That's where we're doing it. This is what that logic looks like. That logic looks like. So we say MO, that equals the result here. And if it equals none, we didn't find anything, skip it. Now here's where we're assigning to a group. We say before part, month part, day part, year part, after part, and we're just picking these up one after another from the group. And every language does it pretty much like this. mo.group1, .group 2, .group 3, .group 6, .group 8, right? Now why did we skip 3, 4, 5, and we go right to 6 and right to 8? I think we get to that in here. Okay, and here's your answer for it, right? When you think about regexes and you see parentheses, and those parentheses are not escaped, you can mentally think that's a grouping. There's something significant about that, right? So that significance can be different. In this case, we see that the first one we capture is this, and the significance of it is it's all text before the date. The second group that we capture is 1 or 2 digits for the month, right? And the third group is one of those digits, right? We don't go through that in this because it's not useful. It's called a subgroup, right? So the reason why the subgroup isn't useful is, let's go back up to the regex. Let's take a look at it so we can see one. We have this here. This whole thing is useful that I'm highlighting. That's what we want. But when we say right here 1 or 2 digits for the month, and we say the month has to start with 0 or 1, that's not useful, right? Because in no way does it matter. The only thing that number would tell you is whether or not you're in month 10 or 11, right? Because there is no month 12 because we start at 0. So it's going to tell you whether or not you're in November or December. It's not useful. So this isn't useful. This isn't useful here either, right? Because that's just going to tell you the first digit of the day. But the whole thing is useful because it's going to tell you the day, right? Over here, this isn't useful. This is going to tell you the century. But this is useful because it's going to tell you the year. So that's why we skip those numbers when we come down and we see it. 1 is useful. 2 is useful. Skip 3, not useful. Take 4, skip 5. Take 6, skip 7. Take 8. Come up here. Take 1. And then we say take 2, skip 3, take 4, skip 5 right here. Take 6, which is here, this thing right here. And then we say skip 7, which is right here. Take 8, which is right here. And then we come down and we have the same thing. Okay, so now we have all of the different parts that we need, right? And now what we're going to do is we just have to reassemble those parts. And what we're going to do here is right here. So we saw this beast earlier. This is the os.path module, right? And the os.path module is how we can build an object that represents a path, right? And that object is a string. So we can say right down here, os.path.join, and we give it where we want to go. And then we give it the file name that we want it to be. So how do we do that? Absolute working directory equals os.path.abspath. Right? What is that going to do? That's going to tell me, right, whatever directory I'm in. Right? Now, let me tell you right now, if I saw this code, I would probably be like, what the hell? Because that doesn't make much sense to me. There is no real reason why that doesn't just say getCWD. I think that's actually a typo in the book, because we've already learned that function, right? GetCWD gets you the working directory. Does anyone in here know why they're doing this? Robert, am I missing something? os.path.abspath. Why is that not getCWD? Yeah, I don't know. Anyway, so yeah, that's the same thing. It's just a more cryptic way of writing what we've already learned, and he taught us. Yes? Do you have an idea? Am I missing something?
Maybe, maybe it used to be a different directory at one point in time, and then it was changed later, and then they were too lazy to update.
I don't know. I'd have to see a test case for that one. But the thing about getCWD is it's going to tell you wherever you're at, right? It'll tell you whatever directory you're in, and the dot represents whatever your directory you're in.
Yeah, I understand that, but if at one point it was dot cats, then it would have given you the absolute directory, the absolute path of the cats directory. But then maybe they changed it to just dot.
Dot and path used to be the root directory.
What are you saying, Robert?
The only thought is it could make a difference if it's assembly. You know, like maybe
Yeah.
the current directory is assembly for
I don't know. Marco.
AppsPath returns a directory in which the code file is stored, but CWD gives you the current working directory, which is by default where the code is executed.
So if you're executing it with a different.
Ah, that's right. That's it. Marco, you're the man.
I'm a genius. I didn't look that up on Stack Overflow.
You definitely didn't. You definitely didn't just Stack Overflow that. That's an interesting difference. So I mean, there you go. It tells you that you can sometimes overlook that kind of stuff. So let's go over what he just said and what that means, right? When you execute code, you have the directory you executed the script in, right? And then you have the directory which the script can be found in, right? They don't have to be the same thing. And that's what I was just assuming that isn't true. So let's go through that one more time and show, because the author is definitely right and I'm definitely wrong on that one. We have here, if we do, what in the hell just happened? Okay, there we go. Okay, yes, I'm floating. Okay. What we're going to do here is I'm going to take it and I'm going to show you this. If I do this, right, exit out of that, ls. If I go here into make dir test, make dir test, cd test, and then I go here make dir, right, and then I have inside of my directory, I have a directory called foobar, right. Now I'm going to go into foobar, and what I want to do is I want to edit a file called test.py, and I'm going to say here import os, and I'm going to say print os.path.abspath, print os.getCWD. Yes. Okay. Live coding may work for me. You can see here, when I run both of these inside of the same thing, right, getting the absolute path and getting the current working directory, when I'm inside the same directory with the script, right, I get the same output, right? But here's the difference. If I go out of directory, and now I have to say Python foobar test.py,
I just realized my explanation was leaving something out.
yeah, your explanation was leaving something out. I want everyone to bring a tomato for Marco next time. Thanks, buddy. Okay. Marco, finish the rest of that Stack Overflow post.
Don't understand. Isn't it?
I will look this up later. The point here is I didn't know originally what it was, and what Marco said sounded extremely intelligent and clarified things to me in a way that not even the Python programmers understood. So we will later revisit that, and we'll find out what is the difference between these two things.
It shouldn't make a difference because dot represents the current working directory, and you're telling it to basically do the same thing. It's almost like it's an alias for one another.
I was assuming the dot was relative to the script, but that is clearly not the case. From Marco was telling me earlier. That's what I was assuming. I was assuming getCWD would be where I'm executing the code, and the dot would be relative to the script. But that is not the case. They are both relative to where you're executing the code. Therefore, my original contention of what in the hell is he doing is still valid. Okay, so I take back that, I don't know. I'll figure it out later. Coding doesn't have to be miserable. It can sometimes be confounding and fun.
Humiliating.
I lack the sense of dignity to be humiliated.
If you're a coder, it's confounding and fun. If you're not a coder, then confounding is not fun.
I see. Well, you'll get there. You'll get there one day. God is a comedian playing to an audience too afraid to laugh. Okay. So we have here, get the full and absolute paths, os.path dot, right? Then we have the absolute working directory. And what we do is we say os.path.join, and we give it the absolute working directory. And then we give it an emir file name, right? So the emir file name thing, that is whatever file we find. So what we're doing here is we're creating our original name, right? The name of the file we're at. We're creating that name exactly, the absolute path to that file. And then we're creating an absolute path to the file that we're going to save. So we create up here a new name for the file. We're saying, okay, we've broken apart that file into different parts. Now we're going to reassemble them like the European Brexiters want. And now what we're going to do is we take our original file and we get the absolute path of that file, and then we go and we try to move it to the new European file name, right? So we rename files, print. Renaming S, which is string, we went through this too, print. We're saying rename this thing to this thing. And our first thing is emir file name, and our second thing is Euro file name, right? So we're renaming the American file name to the European file name, and after we do it, which we do right here, or before we do it, we're telling you what we're doing, right? So we say print renaming, and then we call shutil.move. And Bob's your uncle. You're done. Okay. Ideas for similar programs. There are many reasons why one might want to rename a large number of files. To add a prefix to the start of the file name, such as adding spam underscore to rename eggs.txt to spam underscore eggs. To change file names with European styles to American styles, to remove zeros from, I think we just read that, didn't we? Didn't we just read that? I think that was actually verbatim from a different part of the same book. Okay, so the next one that we're going to be doing here is we're going to be backing up a folder into a zip file. Right, so this is where you're trying to create your own archiving script, which is a fun practice, but you should never trust your own programming for your own backing up, because if you're foolish enough to lose it for the first time, you're probably too foolish to back it up. So rely on other people to do that. But here's how you would do it. Figuring out the zip's file name, right? We create this thing called backup.zip, and in that backup.zip, we give it a folder name, right? So what we're doing here is we're creating a zip to backup through this function we're going to create called backup2zip, right? So we're creating a function called backup2zip. It's going to take a directory and it's going to back it up to a zip file. So here's how you pass in that argument. You pass it in as a folder, right? We've all seen the function syntax. We remember it, right? Anyone have any questions about it? Give me a shout. Okay, so you give it a folder and we say here folder equals os.path.absolutepath.folder. So what if you give it a relative name for the folder? You can't assume it's an absolute path. That's really the problem here. So we're not assuming we get an absolute path for a folder name, right? We're accepting that we may get a relative path to a folder name, and if we do, we're going to make it an absolute path. This is almost always seen when working with paths. When you talk to users, they always talk in terms of relative paths. You know, it's in my home directory. well, who the hell are you? You know, if you have 3 people on the computer, Bob, Mary, and Sue, and they all say it's in my home directory, you know because you're talking to them, but you have to write that down in code. So this is the way the computer translates boss speak into file system speak. We get that absolute path. Then what we're doing here is we say number equals 1, and we say while true, which is an infinite loop, right? So if it's an infinite loop, you automatically know that somewhere in that loop there has to be a method to break out. Otherwise, you're not going to get the results you want, and your computer will forever be busy. Then we say here zip file equals os.path.basename, and we give it the folder name. Now notice we got the folder up here, right? So we give it, we take a name, we convert it to an absolute name, rewrite it. Now we have an absolute folder name. And now what we're doing is we're taking that absolute folder name and we're saying we want to get the base name of it, right? And then we want to add to it underscore string number dot zip, right? So what is this doing? If I give it foo, I get the absolute path to foo, and then what I'm going to have is I'm going to have foo, the absolute path to it rather, foo underscore 1 dot zip, right? If not os.path exists, file name, that's saying if the file doesn't already exist, break out. If it does exist, increment the number, right? So what we're doing here is we're saying, I want to find the first zip file that I can create to represent this directory. So think you have a directory and you have 5 files in it. You run the script the first time, and you're going to get the name of the directory underscore 1.zip. You run it the second time, you're going to get the name of the directory underscore 2.zip, and so on and so forth, right? You want to always get the next increment that's available, and that's how we're doing it here. We're not actually creating the zip file here. That's just trying to figure out what we can create the zip file as. Then we create the zip file, which remains an exercise to the reader. We'll probably do that later. And then we walk the entire directory tree, and we compress the files in each folder, right? So this is where we're going to call os.walk, and then we're going to call zipfile.add or whatever. I don't know if it's .add, but it'll be something like that. And then we call at the bottom, backup to zip, see delicious. Now notice we have created a function up here called backup to zip, and we're only ever calling it once with see delicious. So we can call it on however many directories we want, but that's what we're doing here. Okay, so let's take a look at this here because they're introducing this now. This is called the shebang line, right? I don't know if we haven't went over that so far, so let's give that a shot. The shebang line tells you what kind of script you have that you can execute, okay? Now, for a long time, this was something you couldn't do at all with Windows, and I don't know if they fixed it because I don't use Windows too often. But how it works is like this. With OS X, which is this thing, and with Linux, you can start a file and you put this guy in front of it, right? The hash and the exclamation point. And you will always hear it called shebang. And I don't know why, but I'm sure it's sexist and misogynistic, or that's what I would think.
It's shebang.
Shebang, but it's S-H-E-B-A-N-G.
It's because it's a short form of hash bang.
So they save a character and they switch 3?
No, the hash is the short for the shell. Shell bang, so it's executed within the shell.
The hash is short for shell?
You said the she is short for shell.
Yeah.
The she is short for
Then that-
so you save the L's.
Shell bang, so shebang.
Ah, so you're shaving off the L's in shell, and that's how you get Okay, that makes more sense. That's the most innocent definition I could have possibly imagined for that. Holy shit. Thank you for that. And I actually love computer history stuff. I never knew it, so there you go. So we have this thing at the top, but these 2 characters are very special. This actually happens at the kernel, just so you guys know, right? So this is deep in the bowels of your computer that this code actually sits that processes the shebang. But it looks for these 2 characters. These 2 characters are magical when they're in a text file. And that essentially says this file is not text, right? Because this file is just like any other file you write. If you take it in a text pad and you say, hello world, blah, 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 and then you have this file and you say shebang Python, blah, 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 they're the same types of things. One of them isn't special. They're both text. That's the cool thing about Python. The cool thing about Python is if you see a file that ends in .py, you can open it up as Python programmers and look into it, no matter where that file's at. File ends in .py, it's a text file, you can open it up, you can look at it. That's not true with anything else, with everything else, I should say. If you look at something like calc.exe on Windows, you can't open that one up. It's not text, it's special. Not going to get into that here, but this is what makes your text different from other text. This is what tells the computer your text is actually code that Python can understand. So it's just called the shebang. So you give it the shebang and you say Python 3. And that's telling you what program can read that text as code, right? It's still just text, but it's telling you what program it's significant to. And then all of these other lines are just comments. There's nothing special about them. But this line up here, it's special. So we scroll down and we say do the basics first, add the shebang line to line 1. Okay, now you guys know what that is. Define a backup to zip function that takes just one parameter folder. We just saw that, right? Write a to-do comments for the steps in the source code that remind you to do them later. You don't have to do that. The book likes that. Use a variable named number for n. This is where we're trying to figure out what that new zip file is going to be. And keep incrementing it inside the loop that calls os.path.exist to check to see whether or not the file exists. Keep doing it until the file doesn't exist. Then you have your zip file that you want to save. Okay, and here we go. And now the only difference in this one is that we're actually creating a zip file, right? So now we've done this while true thing, right? And this while true thing keeps going on until it gets an actual spot, which we can save. And then when it does, we break out, and we come down here and we print the name, and we create the zip file, okay? Now we're going to walk the tree and add the zip and add to the zip file, right? So my guess was zip file.add. Let's see what the real thing is. It's actually .write. There you go, right? So what we're doing here is we say we use this traditional. We have all that code that we typed in at the top. That's still there. Notice we still do the -- snip, so follow along. But now we have a zip that we've just created, right? And we have a folder name. So what we're going to do is we're going to walk that folder. We're going to take out of it, remember, os.walk is going to return a, starts with a T and ends with oople. There we go. It's going to return a tuple. And we know that because nothing can return 3 things in Python, right? You can only return a tuple that you can break down into those 3 things. So it's returning a tuple, and that tuple has folder names, subfolders, and file names. And then we say print adding files in, and we take a string, just one, folder name. So whatever that first thing is, adding files in folder name. We say backup.write. We have that zip, folder name, right? So we're writing to the backup zip the folder name. Now we're going to add all of the files in this folder to the zip file. For each file name and file names, so remember, this guy over here is a, that's it. Who said it? You can raise your hand. You got it right. You should be like, yo, I'm over here. If you got it wrong, I would do that, you know? You pass, you have enough humbleness for both of us. Okay, so we have this thing, this file names thing, right? And we say for each file name in file names, right? Now we have this list that we're returning, and we're iterating over that list. And we say here, new base equals os.path base name, and we give it a folder, right? Now where does that folder come from? That folder is the same one we pass to the function. It's the same one we're walking over, right? So we're finding out when we iterate through that directory, we have a structure and a file. We're taking out of that the base, the structure, right? And then we say if file name starts with new base and file name ends with .zip continue. Why are we doing that? We don't want to back up. We don't want to put into our zip file the zip files that are already in the directory. Remember, we're going into the directory and we're saving the zip file in that directory. So when we run it the second time, should we add the zip file from the first run? And we run it the third time, should we add the zip file from the first and second run? We want to skip that. So this is the code here to handle that. Don't back it up. Continue. Skip to the next file name. Right? Then we say if we pass this test, if we didn't continue, then what we're going to do is we're going to say backup zip.write os.path join, and we're going to join all that crap together. So we're essentially going to say if it's not a zip file, then take all of that path that we have, right, the path components we have, and save that thing into our backup zip. And then we say backup zip.close and we're done. And then here's what it looks like when we run it. Adding delicious1.zip, adding files one, adding directory, adding files in rather, adding files in directory, adding files in directory, adding files in directory. You'll notice each time it says adding files, we're processing a new directory, right? Because the os.walk returns one item, one tuple for the directory. And inside of that directory, it has a list of all the subfolders and all the file names. Okay. And I want to take one more note to something here. Let me be sure here before, yes. This is something you can think about too. And this is interesting to think about. Subfolders, we don't use that at all, right? Am I missing something? We're not using that at all. We don't use it at all because it doesn't matter, right? The only thing that matters is what folder we're in and what files are in that folder. If it's a subdirectory, os.walk will go into it for you, and it'll return to you another tuple representing the folder that represents that and all of the files inside of it. So subfolders doesn't matter because this is just things that os.walk will later go into itself.
It matters to OS walk,
Yes.
and that's what the line says.
Well, os.walk is giving you this. It has its own copy. It's giving you back subfolders. It doesn't matter to you. It matters to os.walk. os.walk doesn't have to give it out.
Right.
In some cases, it may matter to you. If you wanted to say, print out all of the subfolders in this folder are this, and then later go into them too, you could do that, if that makes sense. It's really difficult to talk about three different things in terms of just saying folders, you know. But
Saying it doesn't matter, defining it as it doesn't matter to us.
is this application?
Yeah.
That's exactly right, Randy. Yep. Okay. So we say here ideas for similar programs, right? And this is where they tell you how you can waste your own time developing your Python skills. If none of you have ideas of how you can improve your Python skills and sharpen that axe, which you all intend to wield for gainful employment at a later point in time, here are some ideas. And I do suggest them if you're really that bored. You know, I always found programming out of necessity to drive me forward, but if you want to program and you don't have an idea for a plan, hit it off. Practice utilities. What is the difference between shutil.copy and shutil.copytree?
Copy is a single file, but tree is the whole tree structure.
That's exactly right. All right. In the back, let's see if you do this one. What function is used to rename files?
Move.
Exactly. All right, Randy, hit up the next one. What is the difference between the delete functions in send to trash and the shutil module? Send to trash versus deleting. What's the difference?
One does the remove, or the send to trash does the actual move. The utility does the remove tree function. It takes the pointers out.
Not exactly. You want to give it a shot?
So the deletes the file. I mean, it's a permanent whack, but the other one moves it to the trash folder, basically.
Right. Send to trash isn't actually deleting anything. It's literally grandma delete. So grandma delete doesn't actually delete files because we don't trust grandma to competently make a final decision. So what we do is we move all of grandma's files when she says delete to the trash bin. Why? Because when grandma normally throws shit out of the trash can, if she forgets about it, tomorrow morning after she's had her tea and crumpets, she can go digging through the trash can. But computers aren't quite as forgiving. So when grandma sends her, password file or whatever she's saving on that computer, and she deletes that, if she was to delete it for good, she'd have a bad time after she finished those teas and crumpets, right? So we move all of that crap into a special directory. There's nothing special about the trash can. If there's nothing you take out of the class, you can take that out of the trash. The trash can is no different than any other folder or directory on any computer. It is another one by the name of trash, right? It's just, you could rename it. You could call it Bob's Your Uncle and just move all of the stuff into Bob's Your Uncle until you were safe to delete it. That's all it's doing. So this utility here, send to trash, what it does that's unique is, remember we talked about the path name stuff and we said that the path name thing changes from Windows to Mac to Linux and all that other crap? We went through that. We said if you're going to program for all of these different platforms, you got to have more knowledge, a little bit more know-how. Well, the send to trash module is no different. The trash can in Windows is in a different location than the trash can in Linux, and it's in a different location than the trash can in the trash can.
But SHUG does not actually remove the file. It just removes the pointers to the file.
But that is effectively removing the file. If you have nothing pointing to the file, it's gone.
No, you can still.
But
Spent years going and retrieving files where the pointers were removed from.
you're right. But what you're talking about there is data forensics, and it depends on the file system, right? We already went through that. But yes, when you delete a file on a computer, you simply remove the index to it. The computer doesn't know where it's at. It can start to write stuff to there.
Doesn't Python have automatic garbage collection? So in fact, we'll get it.
But that's with Python's memory, not with files on disk.
Oh,
So you're confusing those two things. Anyway, we will go into the technicalities of this after the class. Yes?
It's entirely possible, like if you use the SSD with the discard option, then it will literally.
Remove the file. Your capacitors get drained and it's totally gone. Yes. Let's do that after class, right? And then we'll totally geek out about how files are stored. But the answer to the question for everyone here is that the send to trash module has a function in it that looks like it's deleting stuff. It's moving it into a special magical folder, just like any other folder, and you later empty it out yourself. While the shutil module, it's gone for good. Zip file objects have a close method, just like file objects close method. What zip file method is equivalent to a file object's open method? Now, we went through that in class explicitly, so someone should know it. Anyone want to give it a chance? That's right. You're really good. We need to let other people be really good, though, too, because I want to get some of the sleepers awake. But yes, you are exactly 100% right. When I went through it, and I even said that the zip file method is capitalized and the zip file module name is not, and I drew that distinction, and I said this is a constructor. When I said constructor, the reason why I was saying that is because I want you to see that they're the same. And this is the way the author is trying to drill that point through your head, too. Because when you start to see things in terms of when are you constructing an object and what are you returning, and you start to you get that, it'll make a lot more sense to you. So what he's saying here is a zip file, you have to have a method of creating a zip file, right? The method of creating a file is open. How do you create a zip file? How do you construct a zip file? If you're really pretentious, how do you instantiate? Okay, practice projects. For practice, write programs, do the following tasks. We are not going to do any of those because we have 6 minutes and because I hate live coding this shit. If anyone wants to do any of them, we can cover them in the next class, or you can ask on the Discord channel. If there's anyone who's not in the Discord, find someone today in the classroom, get in touch with them, join the Discord, give a shout out in the Python channel because that's the class. If you have free laptops, wait, don't pack up yet. I haven't hit you up, and I'm not passing around a collection plate. I'm just taking your old shit. If you have free laptops laying around, I'm serious. There are still people with 8-year-old laptops. We have put them to good use. In this class, someone got one, and yet we can distribute. Something we can do. All right. Thank you, everyone. Does anyone have any other announcements? Are we good?